Hello everybody. For this video we're going to be taking a look at a new concept called the tangent ratio, and we're going to actually take the section 8-5 note sheet and we're going to break it into two parts. And so this will be part 1 of the 8-5 notes, where we will define the tangent ratio for an acute angle. In part 2 we'll work on the second objective here, which is solving right triangle problems by using the tangent ratio. So, first of all, a little background information. What we're getting into in this section is we are getting into an area of math called trigonometry. And trigonometry sounds like a big, scary word, and it's probably something you've heard before, and it sounds like it's got to be really, really hard math, but really what it is, a loose definition of trigonometry is the study of the relationships between the angles and the side lengths of triangles. And for this class, what we're going to be doing is studying geometry as it relates specifically to right triangles, or what you'll sometimes get get described as right triangle trigonometry or right triangle trig. And that's what we're going to be concentrating on later on as you move on to more advanced classes like Algebra 2, trigonometry, or a standalone trigonometry class. You'll get into trigonometry related to non-right triangles, acute triangles, and obtuse triangles, and some more applications of trigonometry. Now, in this diagram, what we have right here is we have a right triangle, and I've marked angle A. I've kind of put a mark on angle A. Now, if we label the parts of this right triangle like we've done in the past, we know that across from this right angle is segment AB, and segment AB could be labeled as the hypotenuse of this right triangle. And we also know that in a right triangle, the sides that are not the hypotenuse they get called the legs. So we know that segment BC is a leg, and we know that segment AC is a leg. But for the purposes of what we're going to learn about in this video, the tangent ratio, we need to get a little bit more specific rather than just calling leg and hypotenuse. We need some more specific names. So, from the perspective of the angle that's marked, angle A, this segment over here, BC, rather than just calling it the leg, or one of the legs, we are going to call it the opposite leg. And the reason why we're going to call it the opposite is we're looking at angle A, and of course we've dealt with this idea of sides that are opposite angles before, and from the perspective of angle A, segment BC is opposite angle A, so we are going to call it the opposite angle, or I'm sorry, the opposite leg. And segment AC down here, we're going to give that a more specific name rather than just leg. We notice that segment AC is one of the sides of angle A along with the hypotenuse, segment AB. Segment AC is one of the sides of angle A. And what we're going to do is we're going to call this the adjacent leg. Adjacent is a synonym for like next to, right? So when something is adjacent to something else, it's next to it. And we can see this leg right here is next to or adjacent to the angle that we've marked. So we're going to call segment AC, we are going to call it the adjacent leg. And so that terminology is going to be used a lot in the next couple sections talking about trigonometry. So from angle A's perspective, we have the opposite leg across over here, and we have the adjacent leg next to the angle. If we compared the lengths of those two segments, segment BC and segment AC, if we made a ratio out of segment BC's length and segment AC's length, in other words, if we did the length of BC over the length of AC, that ratio would be called the tangent ratio for angle A. Specifically, we can define the tangent ratio for angle A. We can define it this way. We can say the tangent of angle A is equal to the length of the opposite leg, divided by the length of the adjacent leg. Now, of course, we know that in this specific picture up here, the length of the opposite leg is BC, and the length of the adjacent leg is AC. But we probably don't want to write this much down from this point forward when we're working with this idea of a tangent ratio. So I'm going to shorten this down, and I'm going to say the tangent, and that gets abbreviated to just TAN, but we still say tangent, we don't say tan. The tangent of A is going to be equal to opposite over adjacent, and we recognize that this means length of opposite leg divided by length of adjacent leg, but you'll hear me say it from this point forward as just opposite over adjacent. So this is this is kind of our introduction to this idea of trigonometry, that if we're looking at angle A in a right triangle, if I wanted to know what the tangent ratio is for angle A, I would just take the length of the opposite leg and divide it by the length of the adjacent leg. And that's what the tangent ratio is. So let's do one quick example right here, and that'll be the end of part one, and then we'll come back and we'll pick it up from this point forward in part two. So what we're going to do in example one is we are going to find the tangent of angle X and the tangent of angle Y for this triangle right here. So let's start by looking at the tangent of angle X. Now we know that the tangent of angle X is going to be length of opposite leg divided by length of adjacent leg. So let's real quick look at this picture and figure out, well, what is the opposite leg and what is the adjacent leg? Angle X is the angle that we're worried about right now. Across from angle X, this is my opposite leg. So my opposite leg in this instance is segment YZ, which we know has a length of 20. So 20 is going to be the top number in my tangent ratio for angle X. The bottom number is for the adjacent leg. If here's the angle, then that right there is going to be my adjacent leg. So in this case, the adjacent leg is XZ, which has a length of 13. So the tangent of angle X is 20 over 13, which is about equal to this. If you take your calculator and you divide 20 by 13, you get a pretty ugly long decimal. And we're going to cut that off at 4 decimal places. So I guess that's technically the 10,000th place. So we're going to write that as, if I type 20 divided by 13 in my calculator, I get about 1.5385. So the tangent of angle X is either, you could write it as 20 over 13, which actually does look a little bit nicer, or you could write it as about 1.5385. And that's the opposite side of X divided by the adjacent side. Now we're going to look at the tangent of angle Y. I'm going to switch colors here. I'm going to do the tangent of angle Y next. Now this is still going to be opposite divided by adjacent, but since now we're worried about angle Y, this, which was the opposite for angle X, it's not the opposite anymore. It's not across from angle Y. This side down here is. So let me grab my eraser real quick and let me erase off some of this information that we had for when we were doing tangent of X. So let's see if I can get rid of all this, some of this blue writing here that was for angle X, and let's replace it with what we know about Y. For Y, the opposite leg is this side over here, which is XZ. So XZ is the opposite for angle Y, even though it was adjacent for angle X. Now we've kind of shifted our perspective, and XZ is now opposite for angle Y. So the 13 is going to be on top. This side right here, this is now my adjacent leg, right? It was the opposite leg for angle X, but it's going to be the adjacent leg for angle Y. So YZ is my adjacent leg for angle Y, which has a measure of 20. So the tangent of Y will be equal to 13 over 20, and you can leave it as that, or you can type in 13 divided by 20 on your calculator, and that one does come out a little bit nicer. It comes out as exactly 0.65. So the tangent of X, 1.5385, tangent of Y, 0.65. They both use opposite and adjacent, but we have to realize that when we change the angle that we are trying to find the tangent ratio for, it changes what's opposite and what's adjacent to that angle, which leg is opposite and which leg is adjacent. So keep that in mind. So now we know a little bit about the tangent ratio. In the next video, we're going to see how we end up applying the tangent ratio to solve some questions involving right triangles and missing angles and missing sides. But that's all for now, so I'll see you in the next video.